In this lesson, we're going to talk about periodicity. And the idea of periodicity is that on the periodic table, there are properties of the elements that can be predicted by their location on the table. So these properties change as you either go across the table or down the table in a very predictable manner. And these properties include atomic and ionic radii or radius, ionization energy, electron affinity, and electronegativity. So we'll talk about what each of these are and then how they change as you move across the table. So let's start again with just a definition of periodicity. So these are predictable physical and chemical trends that occur as one moves across a period or down a group in the periodic table. And then there are those properties listed again. The first one is atomic radius, and the atomic radius is just related to the size of an atom. So if we have an atom, we have the nucleus in the center, and then the electron cloud that surrounds it. The distance between the nucleus and the edge of that electron cloud is referred to as the radius. So it is just basically the size of the atom, not the mass. Okay, this is not related to how much it weighs, but its size. As you move down the periodic table, the atomic radius or size increases. And as you move across the periodic table, the radius or the size decreases. So increases as you move across, decreases as you move down. Therefore, the smallest atom on the periodic table in terms of size is actually helium. Helium's size is actually smaller than hydrogen. And the largest on the periodic table is francium, or the largest thus discovered. There is a search for element 119, which they think will go here on the periodic table and be the largest element. All right, so here are those trends again and an explanation. It's important that we not only understand what happens, but why it happens. So as we move down a group, as we go down the periodic table, each row adds a new shell. Okay, so if we're thinking about, okay, here's the nucleus, and then the electrons are in these orbitals. So on the first row, you only have one shell, or one orbital. And then the second row has another shell, or another orbital, and the third row has another shell, or another orbital, and so on and so forth. So as those orbitals are added, sorry, that's pretty messy, but you can see that the atom is going to, of course, get bigger as those orbitals are added. So the valence, the outer electrons, which is where we're measuring from for our radius, those outer electrons have more energy and are further from the nucleus than the row before. So that was pretty self-explanatory. As you move across the periodic table, the atoms actually get smaller. And this can be confusing because the numbers are getting bigger. So we think the atom must be 2. But they actually get smaller as you move across. And the reason is because all the way across, they all have the same shell. So if you're on the second row, all those elements on the second row have 2 shells. All the ones on the third row have 3 shells. So they're all on the same shell. But as you move across, more protons are added. So you have more positives in the center. And that positive in the center is attracting the electrons on the outside. So as the positive in the center gets bigger, it is going to pull those electrons in tighter, thus making the atom smaller. So more protons increases the force of attraction, therefore decreasing the radius. Right? So that's the reasoning as you go down and the reasoning as you go across. All right, now let's talk about ions. An ion is formed when an element loses or gains electrons. So metals tend to lose electrons to form what we call cations. And you can remember the cation has a T in the middle, which kind of looks like a plus sign. So cations are positive because they've lost electrons. Nonmetals, on the other hand, tend to gain electrons to form anions. So we have cations that have lost electrons, and anions have gained them. So you see metals over here on the left except for hydrogen, and then nonmetals on the right, except hydrogen is also a nonmetal. So these metals on your left, they're going to tend to be positive if they take a charge because they've lost electrons, and then your nonmetals are going to tend to be negative as they gain electrons. Okay. Let's look at the effect, though, that has on the radius, or the size of atoms. So starting with potassium, normal potassium has a radius of 227 picometers. That is 4 layers in its shell because it is on the 4th row. But if potassium loses an electron to become K+, its radius decreases drastically down to 133 picometers. So look at that large change there. And the reason for that is because in losing that 1 electron, it loses that whole 4th shell. So now it only has 3 electron shells. Okay, so cations, positively charged atoms, are smaller than an atom with no charge. Same thing for strontium. Strontium is actually on the 5th row, so it has 5 energy shells. But if strontium loses 2 electrons to become +2, then it will lose that whole 5th shell. And notice the drastic decrease in its radius when it does so. So the radius of the atom is related to the number of protons as well as to the number of shells. So if we change the number of shells by decreasing the electrons, the atom will get much, much smaller. Notice that strontium with its +2 charge actually becomes smaller than potassium. And this is kind of an anomaly, but it has to do with the fact that strontium has a lot more protons, so it's going to pull those electrons in tighter. All right, now the opposite is true for an anion. So if an atom gains an electron, it's actually become much larger. For example, chlorine has a radius pretty small of 99 picometers. But if it gains 1 electron, it actually almost doubles its radius. The reason for this is because the protons in the middle aren't changing, and those protons are what are pulling the electrons in. So when you add an electron, your proton number is now less than your electron number, so it can't pull them in as tightly, making the atom much, much larger. Same thing happens with oxygen. Oxygen likes to gain 2 electrons to be like neon, but in doing so, it almost doubles its radius as those 2 electrons are now much greater than the number of protons. All right, so here is the explanation for that, and it is similar to the explanation for just radius in general, but as you move down a group, if you're looking at ions, the radius will generally increase as the number of shells increase. So going down a row, our radius is going to increase simply because we're adding more shells, even if we're talking about ions. As we move left to right, if we're looking at cations, the radius will decrease because the number of protons is increasing. And that's what it means by effective nuclear charge. The nucleus has the protons in it. So as the proton charge, the number of protons in the nucleus increases, the radius will decrease because it's going to pull that in. However, when you move to anions, when you move from cation to anion, anions are going to be much bigger. However, if you're comparing 2 anions, they're both negative, then it is still true that it continues to decrease as you move from left to right. So when you're moving from left to right, as long as it's positive, they're getting smaller. And then the first anion is going to be really big, and then they'll get smaller again as you move across. So it's two different groups. The positive ones decrease across, the negative ones decrease across, but if you're comparing positive to negative, the negative are, of course, going to be larger because they've gained electrons, whereas the positive have lost those electrons.